We are up to lesson 1-7, the distributive property. I have labeled my homework notebook. I have put the date over here. Of course, I never do exact, but today is one sunny day right here. Then your vocabulary for this lesson. We've got, looks like 5 terms I'd like you to write down. Distributive property, term, constant, coefficient, and like terms. You go ahead. Get that done. No. Let's get these definitions written down. Distributive property. It's called the distributive property because it lets you distribute, which, makes sense. First, I wrote down an example that's obvious so you can see how it works. 2 times the quantity, 3 plus 4, is the same thing as 2 times 3 plus 2 times 4. Check that out in your head. 3 plus 4 is 7, times 2 is 14. Is that equal to 6 plus 8? Sure is. There's your test. It works. In more algebraic terms, we say A times the quantity of B plus C is the same thing as AB plus AC. Next word, term. A number, or a variable, or a combination. For example, this, it's not even an equation here because I didn't set it equal to anything. This addition problem, 3a squared plus 4ab plus 6c. Each of these things, 3a squared is one term, 4ab is another term, 6c is a third term. There are 3 terms in this equation. Not equation, in that math problem. Constant is your next word. A constant is a term with no variable at all. 3, -6, 3/2. There are no constants in this example. They all have variables with them. This one up here, these are all constants. Next vocabulary word, coefficient. A coefficient is a numerical factor of a term. Come back up here. 3 is the coefficient of 3a squared. 4 is the coefficient of 4ab. 6 is the coefficient of c. And last but not least, like terms. Terms with the same variable. The exact same variable. To come back to this example again, a squared is not the same variable as 4ab. A squared, not even the same variable as a. It has to be exactly the same thing. Like terms is soon going to become very important in your life. We are just beginning to really get into algebra with this section, and then in the next lesson we get even more into algebra. I'm very excited about that. I'm going to change the format of this lesson just a little bit. Instead of assigning you all the Got It programs problems for homework, I'm going to kind of do them with you on the video, and then your homework will come more from the problems at the end of the lesson. Let's work through some of this. I'm on page 46. They have a nice example of a Tetris game. It's always funny to me, of course they don't refer to this as Tetris because of copyright, but we all know what it is. Let me zoom out a bit. Here's a model in case the distributive property is still baffling you. It's another way to look at it. You can read that over. Here are just some examples of the distributive property. This first one is kind of the classic one. A times the quantity B plus C equals AB plus AC. You can flip it around backwards. The quantity B plus C times A is the same thing as BA plus CA. And then they have some examples with subtraction. They give you samples with actual numbers. And if the distributive property is giving you a hard time, work through these examples so that you can understand that it's equal. Make sure you know how that works. Let's move on to page 47. Problem 1. Simplifying expressions. What is the simplified form of each expression? Simplified means there are no parentheses, there's nothing else that you can combine together. So even though this is pretty simple, we can do something else to it. What can we do? We can distribute. 3 times the quantity x plus 8 equals 3x plus 3 times 8. And they show you here, they just wrote down distributive property so that you would know how we got to here. Work that out. 3x plus 24. This is considered a simplified form of what we started with. Letter B. The quantity 5b minus 4 times negative 7. Distribute the negative 7 gives you 5b times negative 7 minus 4 times negative 7. This is a minus sign here, so when you distribute that negative 7, this stays negative. So you end up with negative 7 times positive 5 gives you negative 35b. 4 times negative 7 gives you negative 28, but you're subtracting negative 28, which is the same thing as adding 28, and that's your simplified form. Now, like I said a minute ago, I'm changing what we've been doing a little bit. Take a look at these 4 got it problems, A, B, C, D. I want you to work through them, but I'm going to stop the video. Well, okay, you're going to stop the video. And when you start the video again, I will be going through these and answering them with you. So, I guess I can't really twiddle my thumbs because I've got some work to do. Get going. So, here's what I expect. If the problems in this got it are really easy for you, go ahead and do them. You don't have to go slowly and follow me, but check your answers as I go through this video. If these problems are scary for you, or you're not certain or whatever, then follow what I do. Make sure you have the right answers. You should still have the answers to these written in your homework notebook. We're just going to end up getting them checked as part of watching this video. So here's the first one. Letter A is 5 times the quantity x plus 7. Well, we're going to distribute this 5 over this x and over this positive 7. So we end up with 5x plus, I could write down 5 times 7. I'm feeling confident I'm going to go ahead and write down 35. All right, that is as much as you can simplify that expression. Come on to letter B. Letter B, we're going to distribute the 12 over the 3 and over the negative 1/6t. So 12 times 3, that one's not so bad, 36. This is negative, so it's going to be minus, I'll do this in a couple steps. 12 times 1/6 times t. 12 times 1/6 is the same as 12 over 6, which is the same as, that's right, 2. So 36 minus 2t. That's as much as you can simplify that one. Letter C, decimals. For some reason, this always looks backwards to me, so when I'm doing problems like this, I usually rewrite it and put the 3 in front, times 0.4 plus 1.1c. So we're going to distribute the 3 times 0.4 and times 1.1c. 3 times 0.4 is what? That's right, 1.2. Plus 3 times 1.1 is going to give us 3.3c. And that's as much as we can simplify it. We can't add these because this one has a c and we don't know what c is worth. Letter D, again, I feel like this is written backwards. I don't suppose it is. There's no right or wrong for that. But so I'm going to say negative y, 2y minus 1. Negative y times 2y is going to be negative 2y squared. We had a negative that we had to distribute. We also had a y. Y times y is y squared. Let me say that again. Negative y times 2y is going to give you negative 2y squared. If that confuses you, make a note in your book right now so that you remember to ask me tomorrow for some extra help. Negative y times negative 1 is going to give you positive y. This is as simplified as you can get with this. You can't combine that anymore because this one's a y squared and that one's a y. These are not like terms. Moving on to problem 2. Recall that a fraction bar may act as a grouping symbol. That was a question on the homework not too very long ago. A fraction bar means division. Any fraction written like that can also be written as this. A over b is the same thing as a times 1 over b. These are basically, we're learning all these little tricks. We're learning how to manipulate numbers legally, if you will, because you're going to do a lot of manipulation when we start working with equations a little more. So given this, what is equivalent to 7x plus 2 over 5? Well, they chose to express this by taking out 1/5 times the quantity, 7x plus 2. And then they distributed the 1/5, and then they simplified it that way. I'll be very honest with you, I learned how to simplify something like this a little bit differently, and either the way that I just went over in the book or what I'm about to show you is fine. You know that you have to have fractions with the same denominator in order to add them. So what I learned to do is just simply, well, 7x plus 2 over 5 has to be the same thing as 7x over 5 plus 2 over 5. Ta-da! Now we are looking at got it number 2, and just like I said before, I'm going to go through these kind of slowly. I want them in your book. Either work through them with me on the video or do them on your own and then quick check your answers. So here's letter A, 4x minus 16 over 3. I'm going to do this first one my way. I'll do letter B the way they have you do it in the book. This is the same as 4x over 3 minus 16 over 3. How do I know that? Well, because in order to subtract fractions, they have to have the same denominator. So that's just how it works. Now, with letter B, 11 plus 3x over 6, the way they showed in the book was take out the 1/6, multiply the whole thing times 11 plus 3x. So that will be equal to 11/6, because now we're going to distribute this 1/6. So 1/6 times 11 is 11/6. 1/6 times 3x is 3x over 6. But yay, it's our lucky day. We can actually reduce that. I don't want to make my book look all gloppy because my marker's so fat. I'll switch to the pen. We can cross off that 3, cross off that 6. That 6 becomes a 2. So either 11/6 plus 3x6 is correct, or you could also say 11/6 plus x over 2. And if you were really good and you turned this into a mixed numeral, that's also fine. Letter C, 15 plus 6x over 12. I'm going to go ahead and do this my way because I just like that way better. That becomes 15/12 plus 6x over 12. Well, this you can reduce. That becomes 1, and this becomes a 2. So you end up with 15/12 plus x over 2. If you want to, you can reduce this. What does that reduce to? Y, that's right. Let me see. 5/4. And extra bit of math fun knowledge for you tonight. Did you know that x over 2 is the same thing as 1/2 x? I hope you did. Last but not least, 4 minus 2x over 8 is the same thing as 4/8 minus 2x over 8. This reduces to what? That's right, kids, 1/2. and this reduces to x. Oh, rats! Didn't have any of that on the screen. Okay, this becomes 4/8 minus 2x over 8. 4/8 reduces to 1/2. 2/8 reduces to 1/4, so that becomes 1/2 minus x over 4. Hopefully all those made sense to you. If not, make a note in your book. Ask me about it tomorrow. We're going to fly through problem 3 because you just don't need all this fuss over this easy idea. I don't know that I'm ever going to ask you what the multiplication property of -1 states. I think, anyway, you know that the opposite of 1 times x equals the opposite of x. If it makes sense to you, you can rewrite something like the opposite of the quantity x plus 6 as -1 times x plus 6. They're both the same thing. They both mean the same. Well, what is the simplified form of the opposite of the quantity 2y minus 3x? Take the opposite of each term. So this is a 2y, make it a -2y. That's -3x, make it a +3x. It's just not that complicated. There's your answer, right there. The opposite of 2y, +3x. Don't even bother to write got it number 3 in your book. Just work through it with me. Distribute the negative, becomes -a minus 5. Distribute the negative, becomes +x minus 31. Distribute the negative, becomes -4x plus 12. Distribute the negative, becomes -6m plus 9n. Done. So have you ever been working through something with someone and they could just do a math problem in their head so fast you have no idea how they did it? It's because they're really good at using mental math, and the distributive property helps with mental math. Take a look at this example. I'm on page 48 now. You're at a deli. Sandwiches cost $4.95 each. Why can't they just cost $5? I don't know. $4.95 each. What's the total cost of 8 sandwiches? Use mental math. Well, wouldn't it be nice if they actually were $5? It's so close to $4.95. So go ahead, figure it out. What is 8 sandwiches times $5? Scooch down here. 8 sandwiches times $5 is $40. But that's not exactly right because it's 5 cents less. So 8 times 5 cents, 40 cents. $40 minus 40 cents, $39.60. And you look like a math genius because you figured that out in your head without a calculator. Come down here to got it number 4. Julia commutes to work on the train 4 times a week. A round-trip ticket costs $7.25. What is her weekly cost for the tickets? Use mental math. Again, I'm going to step through this next, so your choice. Either work it through and then just stop the video, work it through, check your answer with me, or do the whole thing through with me. You still need to have it in your book. So we've got Julia, and she's on the train, and she goes 4 times a week, and every time she goes, it costs her $7.25, which is so close to $7. So what if we just figure it's $7? 4 times 7 gives you $28. But it's just a little bit more than that because every time she goes, she also pays an extra 25 cents. Oh, but 4 times 25 cents is exactly $1. So 28 plus 1, she spends $29 a week commuting. Much cheaper than gas. Good for Julia. I'm looking now at the bottom of page 48, and this is very important. We actually covered a lot of it talking about vocabulary at the beginning of the video, but it's really important, so we're going to go over it a little bit more. They've given you an expression here so that you can figure out what all of these new words are. They show you 6a squared, -5ab, 3b, and -12 are all terms. They are all terms. 6 is a coefficient. That's the number in front of a variable. -5 is a coefficient. 3 is a coefficient. -12 is a constant. It has no variable. It doesn't change. Therefore, it is constant. So we've got coefficients. We don't have the word variable in here, but if we did, a squared would be a variable, ab would be a variable, b would be a variable. Like terms look down a little bit farther, have the same variable factors. To identify like terms, compare the variables like they've shown below. 7a and negative 3a, what are the variables in each of those? A over here, a over here. Those are like terms. That can be combined. 7a can be added to negative 3a to get 4a, or they can be subtracted or multiplied or whatever you like. 4x squared and 12x squared, what's the variable in this term? X squared is. What's the variable in this term? Still x squared. Those are like terms. You can combine those. Multiply, add, divide, subtract, anything that the equation needs you to do. Take a look at this. 6ab and negative 2a. What's the variable in this term? ab. What's the variable in this term? A. Those are not the same variable. Even though there's an A in both of them, you can't combine it because there's that B over here. Can do nothing with this. Can't simplify it. Take a look at this last example, xy squared and x squared y. What's the variable here? X times y squared. What's the variable here? X squared times y. Those are not the same things. You can't do anything about this either. Cannot combine it. Can't add them, can't subtract them, no, not like terms. So, the top of page 49, we are coming closer to the end. An algebraic expression in simplest form has no like terms or parentheses. So this one is not simplified. Why? Because it still has parentheses and it still has some like terms. This one is simplified. How did they get from here to there? Oh, I think they distributed the 2 and like added and subtracted and combined everything. Let's take a look at problem 5. Same thing that we've been doing. I want everybody to, well, I guess I'll talk you through this one. What is the simplified form? 8x squared plus 2x. Well, do these have like terms? X squared here, x squared there, like terms. Good, we can combine them. So all we have to do is add. Well, 8x squared plus 2x squared, add the 8 and the 2. 10x squared. Done. They took this extra step here to show you exactly why it works. You can distribute and what I need you to know, those terms, those are like terms, so you can add it. That's what I need you to know. Take a look at this one. 5x minus 3 minus 3x plus 6y plus 4. It looks like a mess, but there are a bunch of like terms. We can combine them. So start by grouping them up. We've got 5x and negative 3x. Put them close together. 5x minus 3x gives you 2x. You've got only one y term. Can't do anything to simplify that, so we'll leave it alone. Plus 6y right there in our answer. Negative 3. Positive 4. What's negative 3 plus 4? 1. Put that in your answer, and we've simplified our first expression. Got it, number 5. I'm going to work through them. You're going to work through them. Everybody needs them in your book. I will show you the answers when we turn the video back on. Here we go. 3y minus y. Remember, we can always pretend there's a 1 in front of something. 3y minus 1y. What are our variables? Y here, a y here. Are those like terms? Yes, they are. So can we combine them? Absolutely. What's 3 minus 1? 2y. That's your answer. Letter B. Negative 7 mn to the 4th minus 5 mn to the 4th. What are our variables? Mn to the 4th on this side, mn to the 4th on this side. Are those like terms? Yes, they are. So we can combine this. Negative 7 plus negative 5 is going to give us negative 12 mn to the 4th. Simplified. Done. Take a look at letter C. 7y cubed z minus 6yz cubed plus y cubed z. Well, what are our terms here? We have y cubed z. We don't have a y cubed z here. We cannot combine those two terms. Here we have another y cubed z. We can combine this with this. And remember, this is the same as 1y cubed z. I'll write out this whole thing. 7y cubed z minus 6y z cubed plus 1y cubed z. We can add this to this, so we end up with 8y cubed z minus 6y z cubed. And that is all we can do there. Done. Letter D. That's really long and ugly looking. Take a look at all of the variables here. We've got an x squared. Do we have any other x squareds? Nope. We've got an x fourth here. Do we have any other x to the fourth? Nope. We have a lone x. Any other lone x's? Nope. We have no variable here. Do we have any other terms that are just constants? Nope. And do we have anything else that's an xy? Nope. There is nothing you can do to simplify that. It is done. Last but not least, I'd like you to get in a little bit of practice on this. So, page 49, 1 through 8, please get those done as much as you can. This video I know is running a little long. Remember that I expect you to work for about a half an hour. When you get to that half-hour point, including the length of the video, when you get to that half hour, if you are burned out on math, stop. You're done. You can finish it up in class, or ask me for questions, or whatever is going to work out best. But I would like you to get done number 1 through 8, and we'll check it tomorrow. All done.